Hey guys, so today we're going to be talking about 8.3 distance between 2 points. The TEKS that it covers is 8.7d, which says determine the distance between 2 points on a coordinate plane using the Pythagorean theorem. So we're really just measuring the distance between 2 points, nothing too crazy. Essential question is, how can you use the Pythagorean theorem to find the distance between 2 points on a coordinate plane? So, looking at example number 1, it says find the length of each leg. So what that means is, remember, your legs are here and here. So the length of the horizontal leg is 1, 2, it's 2 units. And then the vertical leg is 1, 2, 3, 4 units. So we just got to plug in our numbers. We can let A equal 4, and we can let B equal 2. It says let C represent the length of the hypotenuse. Remember, your hypotenuse is the diagonal, or the one that connects your two legs, the line that connects your two legs. Use the what? Good. Pythagorean theorem. I'm abbreviating. Pythagorean theorem to find C. Well, your Pythagorean theorem says you're going to do A squared plus B squared is equal to C squared. Alright, now we need to substitute in. We said A was 4 squared plus B we said was 2 squared is equal to, we don't know C yet. Remember, we're trying to find the length of our hypotenuse. So now we need to simplify. 4 squared is 16 plus 2 squared is 4 is equal to C squared. I still don't know C squared. Keep simplifying. 16 plus 4 is 20 is equal to C squared. Now it says, don't forget, when you have to undo or do the inverse operation of a square, because 20 is not equal to C, 20 is equal to C squared. I'm still trying to find out what C is. The inverse operation is taking the square root. So, to get rid of this square, we have to take the square root of that side, but what you do to one side, you have to do to the other. So if we take the square root, your square root and your square cancel out, so you're left with C is equal to, use your calculator. My batteries are low, that's fine. The square root of 20 is approximately 4.47. So I'm going to write C is approximately 4.47, and that's it. So the distance of this line, the length of this line right here is 4.47 units long. Alright, now let's try another one real fast. Approximate the length of the hypotenuse to determine to the nearest tenth. It says without using a calculator. We're going to use a calculator. So you got to find the one of your horizontal. It's 1, 2, 3, 4, 5. The length of your horizontal is 5. The length of your vertical is 1, 2, 3, 4. Okay, so we're going to plug into our formula. A squared plus B squared is equal to C squared. Doesn't matter which one uses A and which one uses B though. So just make sure you only use each one once. Simplify. 5 squared is 25. 4 squared is 16. Simplify more. 25 plus 16 is 41 is equal to C squared. To get rid of this square, we have to take the square root of both sides. So C is approximately, square root of 41 is approximately, I always like to round to 2 decimal places, so 6.40 units. Again, that represents our hypotenuse. Our hypotenuse is about 6.4, and that sounds pretty reasonable because this is 5 and this is 4, and we always know our hypotenuse is the longest side of a triangle. So it's higher than 5 and 4, so we're good, or greater than. Alright, finding the distance between any 2 points. The Pythagorean theorem can be used to find the distance between any 2 points. y1, x1, y1, and x2, y2 in the coordinate plane. We actually have a formula to find the distance, so we don't always have to count and count. So we have a formula, and it's this. In a coordinate plane, the distance between 2 points, let me listen for you again, is Okay, now you have to write this very closely or very carefully because it's very important that you get it right. It's the square root and it goes over everything. You have x2 minus x1 and you square that, and then you add, in parentheses again, y2 minus y1 and you square that. Okay, take time, pause it, and write it down. Alright, if you flip over to the back, in case you get tired of flipping the paper, I wrote it for you. Use the Pythagorean theorem to derive the distance formula. We're going to figure out how the distance formula and the Pythagorean theorem are related. So, to find the distance between 2 points, Q and R, draw a segment, which means a line, and label its length D. Sorry, P and Q. I don't know why I said Q and R. So, I know you can't see the points. The points are supposed to be right here, and right here, and right here. I'm so sorry. So, connect the points. And it says, then draw a horizontal, which means horizontal between P and R, and a vertical between these two. So, we basically just made a triangle. Label the lengths of the segments A and B. So, I'm going to label this A and this B. It says triangle PQR is a, what kind of triangle is this? Right triangle. With a hypotenuse, what's your hypotenuse? It's line PQ. Alright. Since PR is horizontal segment, its length A is the difference between its x-coordinates. So, it's the difference between these two. That's how long A is. Therefore, A is equal to x2 minus x1, because difference, we're always talking about subtraction. Alright, 3 says, since QR right here is a horizontal, it's supposed to be vertical, my bad, vertical segment, its length B is the difference, again subtraction, between its, man, Miss Hitchcock can't type, between its y coordinates. Therefore B is equal to y2 minus y1. Use the Pythagorean theorem to find the length of segment PQ, substitute in the expressions for A and B. So, you remember how we get rid of the square? We take the square root of both sides, right? And how did we figure out what A was again? We'll look up here. A was x2 minus x1, and B was y2 minus y1. So that's how we got our distance formula. If you plug in A, x2 minus x1 squared, y2 minus y1 squared. We are literally using the same exact formula. This is just way more specific. Alright, so a real world problem now. It says, we're going to call her Francesca because I think that's how you say her name, wants to find the total distance between her house on the side of a lake and the beach on the other side. She marks off a third point, so here's her house and then here's the beach. She marks off a third point forming a right triangle. Draw my right angle. As shown, the distance in the diagram are measured in meters. Use the Pythagorean theorem to find the straight line distance from the house to the beach. So again, we're trying to find what is our hypotenuse, and we can always find a missing side of a right triangle by using Pythagorean theorem. So find the length of the horizontal leg. Horizontal leg is this one. It says the length of the horizontal leg is the absolute value of the difference between the x-coordinates. Okay, absolute value, remember, that's never going to be a negative number. It literally is just how many spaces away is a number from 0. So it says find the difference between the x-coordinates. I'm going to circle my x-coordinates. Okay, now I'm finding the difference. Absolute value is represented with those bars. Okay, so if I do 280 minus 10 is equal to, 280 minus 10 is 270. Okay, so the horizontal distance is 270 meters. Find the length of the vertical leg, and the vertical leg is the absolute value of the difference between the y coordinates, because y is y to the sky. So I'm going to circle my y coordinates now. (164 minus 20 is 144. Now you might be asking me, what's the point of the horizontal, or what's the part of the point of the absolute value bars? And the point of it is you can't have a negative distance. So the absolute value bars make sure that you're not having a negative distance. If you did 20 minus 164 and you didn't have the absolute value bars, that would give you a negative 144. The absolute value bars keep it positive because you can't have a negative distance. Okay, so it's the same thing. Then it says let A equal, what did we say A was equal to? We can say A is equal to 270 and B be equal to 144. Let C represent the length. So it says use the Pythagorean theorem to find C. So I have 270 squared plus 144 squared is equal to C squared. Okay, so now I need to simplify. 270 squared, I don't know that. And if you know that, props to you. 270 squared is 72,900 plus 144 squared is 20,736 is equal to C squared. We still need to simplify. We need to add these two together. Your next step says add. So do 72,900 plus 27. We add them together. 93636 is equal to C squared. Now it says take the square root of both sides. So we have C is equal to the square root of 93,636, which is 306. So what does this mean? Her house is 306 meters from the coast. Now, to show you that the distance formula works, I want you to, over here, we're going to use the distance formula. D is equal to the square root of, what was our x value? We need our 2 points. So come up here. I'm going to label this x1, y1, and then it's going to be x2 and y2. Okay, I've come up here and I've labeled my points x2, y2, and x1 and y1, and then x1 and y2, because if you notice, 280 is still the x1 value and 20 is still the y value. Okay, so if we come over here, we're looking for our x2 value first. Our x2 value first. So our x2 value is 10 minus, what's our x1 value? 280. We're going to square that, and then we're going to add y2, which is 20. Sorry, we're subtracting, minus our y1 value, which is 164. We're going to square that as well. So, if you put it in your calculator, because we get a calculator, so why not use the calculator? You can literally type everything in at once, as long as you keep your parentheses and everything straight. So I'm going to do a parenthesis, do 10 minus 280, and I'm going to square that, plus, do another parenthesis, 20 minus 164, close that parenthesis, square that one, because that's where that came from. And then do you see how it started with the parenthesis? That's saying that that's going to take the square root of everything unless I close it. So now I have everything closed together and I want the square root of that. And your square root is still 306. Okay, guys, so it works. It's the same. We're going to do a lot of practice with it. The distance formula is 110% new to 8th grade, so don't stress. You're learning it new for the first time. It's okay. See you later.